Hey boys and girls, this is lesson 3.2, all about fraction circles and equivalence. You're going to need to have fraction circles with you for this lesson, so you either want to get the cards out from the back of your math journal, or you want to have your fraction circles that I have in the classroom with you, because they are going to be useful. Once you get this written down in your notebook as well as the day's date, then you can come on back to the video. Pause me for now. Okay, so here's your first thing. Use your fraction circle pieces to answer the following questions. How many dark greens would it take to cover the red circle? And how many purples would it take to cover the red circle? How many light greens would it take to cover the red circle? So after you had a chance to try and figure that out, then come on back. Alright, well hopefully you figured out that it would take you 5 of those dark greens in order to cover the red circle. It would take you 10 of the purples to cover it, and it would take you 12 of the light greens to cover that red circle. So if the red circle is the whole, then 1 of those dark greens would be worth how much? Think about that for a minute. So the red circle, so we want to talk about the red circle again being the whole, and that's what I've written for you over here, so make sure that's what you're noticing. Here's that red circle. So what fraction of the red circle is just 1 of these dark green pieces? And then what fraction number model shows that 5 dark greens, or 5/5, are equal to 1 red, or 1 whole? So you have several questions here I want you to think through, going with each of the different colors that we were just practicing with. Answer these same kinds of questions, and then when you get that done, come on back. Okay, so hopefully you could figure out that for the dark greens, each one would be worth 1/5, because you know that fraction bar says out of. So when I look at this right here, I say 1 out of 5. So if I look at my dark greens, you can see that I've got 1 out of 1, 2, 3, 4, 5. 1 out of 5 is 1/5. So pretty cool, right? And the number model to show that it's equal would be 5/5. 5 out of 5 would be equal to 1. For the purple, 1 out of the 10 that it takes to fill the whole thing, 1 of them would be worth 1/10. 1 out of the 10. 10 tenths equals 1. For the light green, you've got 1 out of 12. 1 out of the 12 that it takes to cover the red, meaning 1 would be worth 1/12. And the number model would be 12/12 equals 1. Alright, hope you got those. So moving on, when you see the 5/5, 10 tenths, and 10 and 12/12, they kind of look like different numbers. How could they all be equal to 1? Well, hopefully you'd be able to see that there are different ways to fill the same red circle. Because the dark green, the purple, and the light green pieces are different sizes, it would take different number of pieces to fill the circle. You might want to jot some notes to yourself about this to make sure it makes sense to you. Okay, so now let's try to find different ways to fill just half of the red circle. So the whole is still the red circle, but I'm thinking about trying to fill just half of it, okay? So if I look, here's my whole, here's the half. Do you see that I could find different fractions to fill just half? Pull some of yours out so you can see that too. And then let's look at how the fractions would be. So I'm taking it for a half, so that would be true. 2 out of the 4 that it would take to be a whole, so 2 out of the 4 would be half. 3 sixths would be half. 4 eighths, 6 twelfths, 5 tenths. Notice they're different numbers and sizes of pieces, but they can still cover the same area of the circle. In this situation, I'm talking about half of it. The previous one, we were talking about the whole. This time I'm talking about halves. So when I look at these different numbers, they would all be equivalent numbers for 1/2, right? Because they all make up the same, they all cover the same area. And that's what equivalence is all about. Okay? So jot some notes for yourself on that. And then notice that on this page in your math journal, you're coming up with a lot of equivalent names for fractions. Page 71 there. This is where you're going to record some of this. And there's some things that I want to make sure you know before you get onto this. So here's some notes you want to have in your math journal. You want to make sure you know many fractions are fractions of something. For example, half of an orange or 3/5 of a mile, that means that the fraction is part of something. The something is called the whole, and for measures and counts, it's the units. So make sure you're thinking these two concepts through. Know that parts into which a whole is divided must be the same size. You can think about that like fair shares. You wouldn't try and share something with someone and split it in half, but not really in half, so that somebody gets a bunch and someone gets a little. That wouldn't be fair. So fair shares, the parts have to be the same size. The number below the fraction bar is called the denominator. It names the number of equal parts into which the whole is divided. And the number above the fraction bar is called the numerator. You want to make sure these words are in your notes. And the numerator is naming the number of parts that you're actually talking about right now, the ones being represented. For example, if Maya eats 2/3 of a pizza, the pizza is the whole. We can know that the fraction is telling us that the pizza was divided into 3 equal parts, because the denominator tells you a number of equal parts, and that Maya ate 2 of them. The numerator is telling you the ones we're talking about. So that's how that works. Make sure you understand that. And then know that you're going to use your fraction circles now to generate equivalent fractions for these different fractions that are on Math Journal page 71. So get working on that, jotting down at least 3 for each one. Start with that. When you have that set, come on back. Okay, so another thing that we want to look at right now is that you're looking to do some fraction filling. This would help you very much to be able to fill out the journal page that I was just showing you, page 71. So notice that they're telling you the whole is the red circle for each of these pages that are in this lesson. And they're looking for you to cover each region with fraction circle pieces using only one color at a time. So if I'm trying to do this, I want that I'm looking for you to be able to figure out how could I get 2 halves to cover this. I hope you would be able to figure out if I'm trying to do 2 halves, I'm going to do the 2, I believe they're pink, 2 pinks, which would make 2 halves. I have to use the same color. That's what I said a second ago, right? So if on my journal page 71 I'm looking to fill this out, I would be able to put that down. So work yourself through these pages. I give you another example down here. So for number 2, it would be 2 light blues, because 2 light blues would fill this, and that would be equal to 2/6. I could also do it with 4 light greens. 4 light greens then would equal 4/12. So therefore we know that 1/3 and 2/6 and 4/12 are names for the same fraction. They're equivalent fractions. The number and the size are different, but the fractions make up the same area. So we can make sure we record those 3 for the 1/3 on page 71. That's how you're using these sheets to help you to fill out those equivalent fractions on page 71. Pause the video. Get that work done. When you have it, come on back. And here are a few of the different equivalent fractions you may have come up with. You may have come up with some additional ones. If you did, that's awesome. Okay, and that's the part I wanted to make sure you got. Okay, so let's look at some patterns in these equivalent fractions. Notice that in the fractions equal to 1/2, the denominator is twice the size of or double of the numerator. The denominator is twice the size of the numerator. 4 is twice as big as 2, 6 is twice as big as 3, and so on. So that's an interesting thing to notice. If the numerator in the pair is doubled, the denominator is doubled or tripled. So for this, 6 doubled is 12. Well, if I'm going to double the bottom, I'm going to double the top as well. So 2 doubled is 4. If I want to do it again, 12 doubled would be 24. 4 doubled would be 8. So I could say then I've got 8 24ths here as well. So that's something you should be able to notice. If I'm looking for, also in the fractions equivalent to a half, I would notice that the denominators are all multiples of 2. And they're even numbers, because that's what they would be if they're multiples of 2, right? And because the denominators are double the numerator, they're always going to be even numbers, right? The denominators are always going to be. Multiples of 2 would always be, because they're even numbers. If I'm doubling something, it's going to make it an even number. So either way you look at this, that's what they're showing you here. So let your brain start to discover these patterns as well while you're working with fractions. That'll help you to be able to quickly and easily be able to make equivalence. Okay, here's what the home link looks like. You're dividing, number 1, you're dividing it into 4 equal parts, and you're shading a fourth of it. So notice that's what they're asking you to do for pretty much all of those. And then for number 4, you get to make up your own. Make sure that you record the amount you shaded so we can double check it. And then for 5, again, we're talking about patterns. What patterns do you notice in problems 1, 2, and 3 that you could make note of here that will help your brain? These are the problems that are going to count towards whether you have mastered this concept or not. So make sure you're counting it as 1 and 2, 3, 4, 5, 6, 7, 8, 9 problems. That's how many you should be able to have on this home link. So it will be out of 9. And then you want to do the practice parts as well. When you have it all done, come on back and check those answers. And there you go. Out of 9. Make sure that's what you're doing. Okay, talk to you soon.